Okay, today we're going to start our new unit on sequences and series with just an introduction to what sequences are. So we're going to learn what a sequence is, we're going to learn how to write a recursive formula, and we're going to talk about summation notation. So a sequence is just a set of numbers with a particular order or pattern, and each number is a term. So something like 3, 9, 15, 14, or 24, and on and on and on. Okay. A finite sequence n, so if we had the sequence being real simple, 1, 2, 3, 4, and it's done, it's a finite sequence. The first example, the 3, 9, 15, 24, with the 3 dots after, is an infinite sequence. It doesn't end. Okay. When we talk about sequences, we talk about the terms, where a sub 1 is our first term. So in this case, a sub 1 is 1, my first term. A sub 2 is my second term. In this case, it's also 1. A sub 5 means the fifth term, so if I count that out, 1, 2, 3, 4, 5, a sub 5 in this case is actually 5. A sub n means the nth term, or we use that to say any term in formulas. A recursive formula is a formula where the rule in which one or more previous terms are used to generate the next term. So in this Fibonacci sequence, we start with this formula, and what this says is any term is equal to the term in front of it, okay, or the term right before it, and then plus the term 2 places before it. So the Fibonacci sequence, if I start with, let's say I go to 13, and I want to find the next term, so a sub n, the next term, is equal to the one right before 13, which is right before the term we're looking for, sorry, okay? So we're looking for the term after 13, so this would be 13, and then the 2 before it, the 8. So 13 plus 8 is 21, okay? And then the next term would be 21, the term before it, plus the term before that one. So that would be 34. Okay, so that's how a recursive formula works. So if I want to find the first 5 terms of this sequence, and we're saying for the second term. So if I want to find I've already got a sub 1 right here, and here's my rule. We're going to add 8 to the one before it. So a sub 2 is going to be 10, okay, plus 8, which is 18. A sub 3 is going to be 18, the term before it, plus 8, or 26. A sub 4 is going to be 26 plus 8, or 34. A sub 5 is going to be 34 plus 8, or 42. And then we want the first 5 terms for n greater than 2, so we're going to go one more. So a sub 6 is going to be 42 plus 8, or 50. So my terms are 8, 26, 34, 42, and 50. So now let's look at this formula. What's happening? First thing I want to check is you can look and see, am I subtracting, multiplying, what's going on? So if I look here, 4 times 3 is 12, 12 times 3 is 36, and 36 times 3 is 108. So what I'm doing is I'm multiplying by 3. So my recursive formula always starts out with a sub 1 equal to whatever that is, a 4, and then we say the next term would be equal to, we're going to put the 3 in front because we're multiplying by 3, the last term. So we designate that by saying a sub n minus 1. So basically, if the n was 5, the n minus 1 would be the first term, or the fourth term. So that's my recursive formula. Now that's great if you're only finding the first couple terms. But if you want to find the 10th term, like in this example, then that can be tedious. If I want to find the 100th, that can be really tedious. So we have what we call an explicit formula, which describes the nth term by defining a rule for n. So a sub n equals 2n cubed. So I can plug in any number I want now with this formula, because it's not based on the one before, and solve. So in this case, the first 5 terms, a sub 1, I would just plug in 1 to the third power, and that's going to be 2 times 1, which is 2. Okay, if I want to find the second term, I would plug in 2, and that's going to be 16, because 2 cubed is 8. A sub 3, 2 to the third, so 27 times 3 is 50, is 81. The fourth term would be 2 to the fourth cubed, so 64 times 2 is 128. This one's wrong, sorry, a to the third, because 3 cubed is 27 times 2 is 54. Sorry. Okay. And then a to the fifth would be 2 times 5 cubed. So 125 times 2 is 250. And then I can jump to whatever term I want. So I'm asking to find this 10th term. So we say a sub 10 is equal to 2 times 10 cubed. So that would be 2,000. 10 cubed is 1,000. So we can jump to whatever term we want right away with this. Now this is what we call summation notation, and it means find the sum. Okay, this is your rule. Okay, this is your first term, or first, like where you start is a better explanation. It doesn't always have to be 1. And this is where you end. So you're going to have a finite sequence with these. Okay. So if I'm going to evaluate this rule, I'm going to start with 1. So we say the sum of 3n minus 4 from 1 to 4 is 3 times 1 minus 4 plus 3 times 2 minus 4 plus 3 times 3 minus 4, and then plus 3 times 4 minus 4. And I stop because I'm going out 4 terms, or to the fourth, and it would be equal to 4. So 3 times 1 minus 4 is negative 1. 3 times 2 minus 4 is 2. 3 times 3, 9 minus 4 is 5. 3 times 4 is 12 minus 4 is 8. And then I just add that together. So I get 1 plus 5 plus 8, or 14. And that's my sum. So today I looked at all kinds of, we introduced sequences and looked at summation notation. So have a math-tastic day.